So what is the food, energy, water nexus, and why do we have a spaghetti cake here? The question is, if I rename the spaghetti cake a sauce, meat, cheese nexus, does that change how delicious it is, or does that help us understand how it's made? And does renaming the food system and the water system and the energy system and how it interconnects a nexus help us do the same for those systems? The answer is we have to disentangle the spaghetti cake to try to understand it. And how we do that is we have to organize it by how it functions. When we talk about food, energy, and water and how those systems function, we have to ask, what is the purpose of that nexus? And the purpose of that nexus is to take resources from the environment, concentrate them, and deliver them to end users. So the general process is we take biophysical compounds from the environment and push them through a stepwise process of improvement until they finally get to a person that consumes them. At each stage of development, there's a behind-the-scenes influence that happens. At the very earliest stages in the environment, the climate and ecosystem is the driving factor. As we move through and extract it from the environment, that's when policy and management decisions are going to change how we operate. And finally, as we deliver it to the consumer, the number of people and their economic status is going to impact how that resource is consumed. At every stage of the process, other resources are required. You can't spontaneously go from the environment to people. Energy is required and other inputs are required. Each stage and each step up between stage requires a set of inputs and has a set of outputs. Those inputs can be of any nature. They can be energetic, they can be material, or they can be knowledge-based. Energetic inputs include things like the literal energy it takes to boil water, or the amount of gasoline it takes to move a resource from one place to another. Material could be something like the steel you need to build a car, or the water you need to boil to make your coffee. Knowledge-based inputs include things like experience, innovation, data, anything that's going to change the amount of resources that are required to go from one step to another. And what we hope is that reduces those inputs to increase the efficiency of the process. The outputs can be some kind of pollution or something you reuse or recycle to increase utility. Once we've defined these ground rules and how the system operates, it's easy to put the food system, the water system, and the energy system within this framework. Now it's time to put it all together, because some of the inputs that are required to go up stages in, say, food are water and energy. So the whole thing is interconnected. We start at the center, where consumption happens, where people are. Food, water, and energy come to those people to consume. Then we begin to pull back, adding all the stages that are required to get us to that end user. Behind those stages are the processes that most influence them. First, there's the natural cycles. Then there's climate and ecosystems, then policy and management, then economy and population. Now the fun begins. We have the system, but we don't have its connective tissue. We don't have the spaghetti. What we have is a multi-layered structure with people on top. That's our cake. We need our spaghetti. As we add those connections, the water ones first, you see that water is required to make the energy transitions happen. Water is required to grow crops, irrigation. Moving on, we see there's energy required to move water from one stage to the next, pumping and movement and treatment. The food stages require energy to move from in the field to harvest to process food. All of these energy processes release carbon. That feeds back and closes our energy loop. One way to think about it is if you ask Google Maps, how do I get from my house to the YouTube studio? It would give you a path, but Google only needs two addresses, its begin point and its end point. As soon as we have that, it's easy to describe the whole system with equations. So the idea is the nexus really is only a set of processes and flows to take resources from the environment through these steps to our end use. You can only do a few things. You can move stuff from one place to the other, transport it. You can concentrate it or somehow otherwise improve it. Those are the step changes. And then those actions that you take within the nexus all have consequences, pollution, or otherwise return flows. So only 3 flows, only 3 terms in the equation. A nice part about this approach is that we don't have to limit ourselves to food, energy, and water. It works for any resource. So if something else became a bottleneck for the supply of materials for our consumption, we could add it as another stepwise process. And instead of 3 pillars, we'd have 4 or 5 or even many more. Another way to think about this is in terms of our very favorite things to eat or drink. Coffee, a great one, is the flow of both coffee beans that you extract from the environment, harvest, process, grind, and roast, and deliver to a coffee shop, plus the water that comes from a source, is piped and pumped and delivered to that espresso machine. They come together with energy to make your coffee cup. Each step along the way takes energy, and it might even take water. Some of those beans might be irrigated. It takes energy to harvest and transport, grind, and roast those beans. All of those resources are in that cup, even if you don't see them. So that's how we get the spaghetti cake into a formalized equation, so that maybe we can find win-win scenarios and other processes where we can take the resources we have and extend them into the future. I think that pretty much everything in the food, energy, water nexus is contained in there. But if you think there's something that's not, let me know in the comments below and try to stump me. I bet you it's in there. This work was funded by the National Science Foundation. Thank you so much for your support.